Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night, as always. If you're not familiar with the Castlevania Symphony of the Night decompilation project, go to z.dev, where you can see the progress that we've made on several overlays. I have been working on the Long Library, and yesterday we looked at the Flea armor. You can see the Long Library coming along. I think that N01, which is the outer wall, that's actually really close to being completed as well. We could look at what's left there and see if there's anything maybe that it has already been decompiled or that I haven't checked in yet. See if we can make any progress there as well. Yesterday we looked at the Flea armor and got that finished, and I haven't gotten that ready for PR because I was working on a couple other things. The first was the Doppelganger overlay and Doppelganger 10 overlay. So that's a boss within the outer wall, and bosses work like stages. The overlays are basically identical, and they take the place of a single room. And as you go through that room, the game checks to see if you've defeated that boss yet. And if you haven't, it loads the new overlay as you're walking in. Otherwise, you just walk in a room like you normally would. And then I was working on something else. There's a bunch of big backlog of things that I need to get done. But the other was fixing the dupes report. I shouldn't say fixing the dupes report. Improving the dupes report is probably the better way to put it. And so I have a PR out for that in the branch Speedy Dupes. So there's a few ideas in here. It's not everything that I wanted to do with dupes, but it's getting a little closer. There's a few bug fixes and a massive speed up, and I'm going to talk about that in a second. There's actually something I can do to make it a little faster, and we can try that and see if that works well. So unlike most of the stuff that I've done on the stream, dupes is in Rust. I'm not a Rust programmer. Prior to this project, I had never programmed in Rust, and so I've fumbled my way through, and I've done, I don't know, some amount of Rust between this and Sotenlint, which does a lot of linting for enums and things like that. I wrote a bunch of utilities for that to go find, configure and find enums and replace them when they otherwise would be just constant values. So what is dupes? I've pulled up the dupes report in the past. Let me do that now. So we have this report that goes through and tells you what functions are duplicates of one another and approximately how close those duplicates are. So a 1.0 between the top function and everything below it is going to be an exact match within three significant digits, I guess. And so you'll see things like this where in MAD we have these two functions. They've been decompiled, but they have a name that doesn't match what's here. And we also have two names for a function that matches 100% of the time. That's suboptimal because when we do make config, it actually takes this list in the order that it appears, and it's going to choose create entities above for the function name of the first match that it finds. But in actuality, in the overlays, create entities to the right always comes first. I haven't fixed that issue, but that is a known issue. Similar with horizontal and vertical. Fortunately, horizontal comes first, and so that gets named properly. But so we have this report, and it was very useful early on for finding functions in overlays that were the same, so that we didn't have to manually identify those. And when make config comes in, it tries to map function names, function addresses, using this tool for that new overlay. So we know what the functions are before we decompile them, and in the cases where they're the same as something that exists already, we can do a little more, which is import shared code, and then we don't have to deal with that at all. So I mentioned that I was working on the Doppelganger 10 overlay. Let's see, I have a PR out for that as well. So for Doppelganger 10, I was able to go through before submitting the PR, and we have all these symbols that are mapped mostly automatically. I added a bunch more for variables. But then for shared files like collision, we can just import shared data because we know what those symbols are. And we basically know what the order of those symbols are. These are unique to Doppelganger, so we can't import those. But a lot of the other stuff can just be imported. In some cases, functions are slightly different. So we can look at something like this, the entity background block. Entity background block actually is slightly different between stages and bosses for reasons that we don't know yet. But that's what the dupes report does. And so here's where that entity background block matches actually. So this is an awesome report, and it's awesome for especially people who are new to the project. They can come in and say, I think MAD is broken in some way, but they can come in and say, I see that this function isn't named. I'm going to go through and at least rename that symbol. And that's a great way to get started with the project because it's something that's necessary and useful. And let's see if there's any others that are very unnamed. Occasionally we'll see things like this, though, where are these the same? Why would we have the same function multiple times in the same overlay? What is another one? Ulrach's drool. That gets grouped with blood drips. And again, you might find these both in the same overlay. And so are those really the same? And what does it mean to be the same? Is it good enough to be similar? When I started out working on the project, this report was very helpful to me because I didn't know anything. And so if I knew that blood drips was 92% similar to Ulrach's drool, that meant that I could look at blood drips and use that kind of as a foundational basis for my decomp on Ulrach's drool. Sometimes, though, that 92% is misleading. And it's misleading because of the way that we look at and map these together. So I think this is one of those cases here. RA tan 2 getting mapped to some of the sound play functions and something else here again in MAD. I think there's something wrong with the MAD mapping that's causing all that, but not terribly important. So there's usefulness. There's a few quirks. I think in general this report is, and the tool that makes it is one of the incredible pieces of engineering that's part of Symphony of the Night decompilation, and unique to anything that I've seen before, but also unique in that I never needed something like this before. This was, as far as I know, mostly written by Sozu D, and I've gone through and tweaked a few things here and there. There's a few more things that, like I said, I'd like to tweak, but to run this report locally, it takes about 7 minutes. And so if you're importing a new overlay and you want to run the report to see how similar you are to other existing functions beyond what make config would do, you're going to run it and then you're going to wait 7 minutes. And during those 7 minutes, you're not going to see anything. It's just going to be a blinking cursor waiting for the script to finish. And that's because when to create this list, we're doing an n-squared evaluation of every function that has been decompiled or not. And as you can imagine, that's very expensive. Each of those n-squared times, we're doing something called calculating a Levenshtein distance. And the Levenshtein distance is the number of edits that it would take to transform, say, entity as near player to collect dummy. And we have to do it again, entity as near player to artan and animate entity and everything else. Not only everything else, every instance of everything else. So kind of getting back to that similarity. So then we calculate similarity. We have some thresholding, and we say if something is within 90% similarity to another function, group those two things together. And again, that similarity is based on the opcode for the MIPS instruction. And most of the time that's really good, but arithmetic instructions all have the same opcode. So whether you're doing an add, subtract, let's see, what are some of the other ones? Divide, multiply, getting multiply with overflow, high or low, a bunch of these. They all are assigned less than immediate. All of these are, assigned less than and signed less than. All of these have the same opcode, which is 0. And they use another field. And basically, when you think of how processors are architected, what that's doing is saying, I'm going to shift the rest of this data, the other 26 bits in this instruction, I'm going to shift that over to a math coprocessor. And I'm going to let the math coprocessor do, or the math circuitry, I'm going to let that do whatever it needs to do, and then come back, and I expect when it's returned after a clock cycle that the answer is going to be in the register that I provided in the destination register field. And for the most part, that's what happens. So the math circuitry then needs other data to determine what operation it's doing, and it uses, instead of the first 6 bits or the top 6 bits, it uses the low 6 bits for that. So it would be nice if we could not only look at those lower 6 bits, but why not look at everything? When GCC is optimizing a function, most of the time it's just looking at that function and not looking at the context around it. We have some examples of MetroWorks looking at the context around it and actually choosing registers that don't conflict with other functions that have static scope with that. But I don't think we've seen that with GCC of this vintage. So what if we could get all the registers, get the functions, get any immediate values, things like that? And we can, but we have to be a little careful because there are certain instructions that are going to load global addresses, and those global addresses differ for every overlay. So we don't want all immediate values. We just want small immediate values, usually. And again, that's there's kind of some subtlety with that, I'll say. Let me see if I can pull this up again. So originally we were just looking, like I said, at the opcode, shifting over 26 bits, grabbing the last 6 bits. So I've changed that to be aware of the format of the instruction. And depending on what format instruction, it's either going to use the entire instruction, so you get all the registers, you get any immediate values, things like that. For R type, which is, those are the arithmetic functions, you might get the J type, which are jump instructions, and jump instructions use 6 bits for the operation, and then the additional 26 bits it can use for an address. So unlike a lot of the load instructions that only get 16 bits of data, jump type has 26 bits of data, and usually, and especially for the PlayStation, that's enough that it can jump to anywhere in memory. I think that's true. 26 is, yeah, that would be 67 megabytes of address space, and we only have 2 megabytes to worry about. So then you also have the I-type instructions, and these are the immediate instructions where you're loading 16 bits of data into a register or storing 16 bits of immediate data. And so for the J-type and the I-type, we don't want the immediate values there because those immediate values change. There are going to be some I-type instructions where it is a constant value and always will be the same regardless of what overlay that is in. SPIM uses some heuristics. SPIM is the disassembler to figure that out. To do that, you effectively need to emulate a portion of the loads and stores, and that's one of the reasons extracting and disassembling takes as long as it does, because that's a relatively complicated process. So before we were just looking at the op code of the instruction. Now at least we're getting, for arithmetic instructions, everything. For jump type, still just opcode. But then for the I-type instructions, we're getting the opcode and then 2 registers that may or may not be involved, depending on that instruction. So that's nice and gives us the ability to more strictly identify when we're comparing functions what those are. It does mean, though, that we have to use 4 times the amount of memory. Memory hasn't been an issue for this in my experience, so not a big deal. So one of the other things I mentioned was the dupes will sit there for 7 minutes or so and not tell you anything. So I just added some progress. It's optional. You have to provide a flag, but it'll give you some progress, which is nice. And then, so a lot of typing stuff. The big change, and it's down here or up here, I should say. A bug. There's a bug. Originally, I flipped these, but also changed this. So we were looking at distance. Originally, this variable Levenstein similarity was named distance. This was really a value between 0 and 1. And the closer you were to 1, the more similar you were. And the further you were from 1, the less similar you were. But then when we look at this, we're saying if our current distance is less than the closest distance. So we would prefer functions that were less similar than more similar when we're actually trying to do exactly the opposite, which is find functions that are more similar. So I switched those around. And I renamed it similarity to avoid that confusion in the future. But then the huge speed up. So Levenstein similarity, Levenstein distance, is the number of edits. So how many characters would you need to change to transform one string, or how many elements would you need to change to transform one thing into another thing? And if we just purely look at the size of 2 things, so function A is 4 characters or 4 words, function B is 8 words, we would have to introduce 4 words into function A to get to function B, or vice versa. We'd have to subtract 4 words from B to get to A. And so our edit distance is 4. And the way that we calculate similarity is by taking the longer of the 2, looking at the edit distance, so in this case 4, and then just doing the division there. So we'd have to do 4 edits out of 8 instructions that's half the instructions would have to change. So our similarity would be 50% or 0.5. So that that size comparison allows you to do a really fast hack. We don't need to figure out all the edits that Levenshine does. Levenshine is n squared for the two inputs, and so you get a long function, you're going to get a long runtime. We could just look at the length, and that gives us a extremely cheap estimation of what the minimum distance is going to be, and it's constant time. So we go from having to do n squared on functions that may be wildly different to a constant time operation that allows us to skip through. And so Dupes was taking 7+ minutes on my machine earlier, and let me I'll run it here. Let's see if I can pull up my history. I can't, of course, and we'll see how long it takes. And you get to wait, like I do, and wait for Dupes to run. Let me open the makefile, get the command, because I always forget it. So to run Dupes, we go into the Dupes directory. I've built this already, so I'm not going to rerun cargo. I do need to remember the build directory, though. Target. There we go. Another, I think, thing that could change with Dupes is you have to run it from its own directory, and it assumes that you're running it relative. So I'm going to do the same threshold, threshold of 90. Higher thresholds allow you to run faster, but you'll see that we don't need to run faster. I want progress. I want to see what's going on in the output file. I'm just going to write to I guess I'll write it to the same GH duplicates file. And now it's going to run. And so, like I said, you get progress, which is great. I can see how long I'm going to have to be here waiting for Dupes. And that was it. It's done. No more 7 minutes. Now it's about 14 seconds. And we can look at the Dupes tool. A bunch of these that I saved off. And it looks very similar to the previous Dupes tool. One nice thing about adding the additional instructions is there appears to be a lot more subtlety in the difference. So we can look at this versus the other one. So we have entity prize drop here. We have a bunch of functions that probably should also be named entity prize drop, but are not yet. And if we look over at this duplicates report that is published, this one, different reason that these are different. Let me come up with another. Let's do the Olrox tool. That's the obvious one that I saw being different. The lack of names is an artifact of my own extraction. I didn't run any of the prerequisites that would give me the correct names, so excuse that while I run it. Actually, though, that makes this less compelling. So let me just run the target directly. But if I run the target directly, it's going to rebuild, and this is not the branch that I have. So give me 1 second. Tools.make, tool.make, yeah. So I want to, for symbols, and force extract. This takes a little while to run. This usually only has to be done once. This gives you a lot of additional assembly as well, and it mucks with symbol tables, which is less than nice. But all right, and now we can run the tool again. Now it's going to have to go through a little bit more data, but it's still very fast. Not nearly as quick as it was before. But still, it's not 7 minutes. There we go. All right, let's look at Olrock's drool. So we have a bunch of these functions, and the issue here is that we have both matching and non-matchings. That's because I have a clean build. When this is run normally, there's no build to get it from. It bases whether it's matching or not based on the source code, not based on whether or not something is actually compiled into a final binary. So we have all these Olrock's drools, but that's all we have here. And if we look at entity blood drip, that's also its own thing. But when we go back to the normal dupes tool, we look at entity blood drip. Those are the same. They get matched together with Olrock's drool. Is it helpful that those get mapped together? They're 92% similar, so yeah, in a way that is helpful. And maybe there's a better way to do this reporting, and a better way to figure this out. But when these two functions are in the same overlay, both of these being in the long library, for example, we know that they're likely not the same function, same implementation. So really, we just want to look at them for comparison and to make decompiling one easier than the other. Is that useful? Is that helpful? I'm not sure, but it is much faster, and there is a bit more subtlety. We can lower the threshold even more if we want those things to group together, and I think that'll be a nice improvement. I don't think for open source projects that anybody pays for any of the GitHub CPU time or anything like that, but Microsoft, you're welcome. I saved you 6 minutes and 45 seconds every time that this runs of CPU time. Let's go back to decompiling things. So yesterday we looked at this Flea Man armor. Let's try to get this matching in the PSP as well. I've not really looked at the PSP builds for Long Library, and it's a little bit harder to get a match on both right away. Usually the way I like to work is get a match on the PlayStation and then maybe come back later and do the PSP, but it's nice when we have both at the same time. My branch is full of a lot of stuff. I need to clean it up just like my desk and garage. So we have Flea Man armor. What I want to do is look at the overlay for the PSP. We know what the PSP function is. Make sure that that is being split at the appropriate place. Maybe combine the file that both of these are in. And yeah, we'll see where it goes from there. So first I'm going to look for the US library splat file, and this is going to be in Flea Armor. And then I'm going to look at the PSP. Splat file and see if these have been kept up to date, if we have Flea Armor here as well. These are in a different order. C files come first. And so not all of the splits look like they have been made at the same time. So we know that it looks like Breakable is not in the US. Some of these, oh, they're out of order. That's interesting. Or, no, maybe they're not out of order. They're, we just haven't imported those yet. Is that? Or maybe they are out of order. That's possible. So we know what the PSP function was. It was this one here. So we can find what segment that's in. I use grep for that. You can use whatever you want. Not your mom.
You're not my mother!
So I'm going to do a search there, and so it's in this 387 C78. No, that's data. Flea Armor is extracted. What's going on here? Why don't I see a Flea Armor segment? I am very confused. Oh, Flea Armor. I can't read. Yes, and it's Flea Armor in both cases. Okay, so having a rough time of it. So I'm going to look at the PSP version of the library. I'm going to open Flea Armor, and we have two functions here. So there's a couple things we need to do before we can continue. We need to either map all of the data as symbols or import the data. Importing is a little bit trickier, so I'm going to map. And so basically all of the function names I need to make the same on the PSP as they are in on the PlayStation. So I'm going to open the symbol table for the PSP. Actually, I'm going to open the US one first for stage library. Do a split, open the one for PSP. I actually don't need the US one right now. Just open the PSP one. And I think I can get rid of this. And so now I need to find each of these symbols, and we can look at the immediate values to help us determine what symbols we're missing, because they will be named something else. And so here we have this 019 BC, and we can actually look at this list here. This will be the list that we need to map. So I'm going to paste that in here. I'm going to get rid of all of the type information because I just need the symbol name. And as a practice, I find this somewhat disgusting, because we're taking these symbol names that are based on addresses for the PlayStation, and we're assigning them addresses on the PSP. And that's terribly confusing. I don't like it. Not my choice. Actually, it is my choice, and it's the easiest way to do this. Nope, that was the wrong one. This is fraught with peril. It's very important to keep track of which symbol you're assigning an address to. I missed this one down here. Because if you screw it up, your symbol mapping will be incorrect, and then nothing will work, and you'll spend a long time debugging. From experience. All right, so now I'm looking for D8C. What's nice is that these functions are so similar. This one is 278. That we can just map these locations and everything, the code will work and be source compatible with both. D84. No. There we go. One ACC. Have I been teaching the kids Rust? Entropy Gravity Well. Have I been teaching the kids Rust yet? I haven't, and I don't have any immediate plans to. To me, Rust is a lot like Python. Oh, this one's already mapped, which is nice. It is boring in all the wrong ways. Of course, I'm an Apple fanboy, so Rust and Swift were coming out at about the same time, and I spent a long time in Swift. And again, Swift is opinionated, also in a lot of the wrong ways, just different ways. Swift is like the everything language, like any style of programming you want. Swift will allow you to do it, and that's not good either. It's kind of like C++ in a lot of ways, just overly complex. All right, so I have all those symbols mapped. I'm gonna touch the splat config to regenerate the assembly. So now when I run extract, oh, I screwed up. How did I screw up? Duplicate symbol detected. This should be entity Flea Man. And I had fixed that actually on the PlayStation side, but I fixed it in code. So we can get rid of that, and we can rename this entity Flea Man. and do it again. All right, so all of the symbols should be the same. Now, what I should be able to do is, actually I'm going to make sure I have a clean build for the PSP. I don't know what the state of my build is for that. And then I should be able to copy over the Flea implementation. And because I have all the symbols mapped, it should just work. So we have library building, that's okay. So I'm going to open the Flea armor, and I'm going to just take the entire implementation. So I could share these, and I will share them. But before I do that, it's easier. It's a long function. In my opinion, it's easier to do this. And I'm not going to run everything again. I should just be able to make, and there is some issues. What did I miss? I have a syntax error. Oh, I'm probably not including the right header file. Yeah, that's it. Error compiling Flea armor. Let's see. What is M2C not liking? Why do you not like what I've given you? Lib we can't. Okay. Do we have a lib PSP, or can we just include? Yeah, it looks like we can include libs lib. Gotta own those libs. All right, so we have one undefined reference. Did I not fix that? Oh, the undefined references. The fact that I am using the PSP or the PlayStation name on the PSP. Let's try one more time. Wrong make. There we go. Right version. So we have one symbol that was missing, which is this 2DA1 or A4. So let me find that. It's possible that that was in the context and not up in that list. Yeah, that looks like it was where it was. So I need to map that as well. On 189. And let's see if it works this time. Fails. Okay, so let's see why it's failing. Um, just a small difference. Offset 16,580. What do we have different? Here we have a 6.1. Ours is a 6.3. So let's find out what that instruction is supposed to be. Instructions are grouped together like this. They're a little Indian, so you gotta flip them around. Let's find the original assembly and see what's going on. So it could be a type issue. The PSP is definitely more sensitive to type issues than the PlayStation is. I'm going to go look at decomp.me quickly. I say the PSP. It's not the PSP that's sensitive to type issues, it's MetroWorks specifically. Oh, it's here. Register issue. Oh, and this happens from time to time. So there is... we're using AT versus V1, and so this is going to be caused by possibly using the wrong comparison operator. Somewhere around here. So this is it right here. Instead of greater than or equal to, it's just going to be greater than 1,000, and now it works. So we can fix that. Usually I will not go back and copy and paste that again. I'll just find the instruction here and fix it. And I'll make sure to do it on the PlayStation side as well. I was just actually looking at something similar to that. And every time you see an odd off by one error, usually you can, or an odd number that would be a nice round number, were you to change it by one. Usually that's the case. And now I'm hoping that this is going to work, and it does. Great. So the next thing is, we'll probably work to decompile this next function, but in the meantime, I don't really want, I optimally would like to submit this and have this checked in, regardless of whether or not I decompile this other function. However, if I repeat this code twice, that's kind of gross too. So I'm going to put an if-def down here. So if not defined PSP, we'll do the other one. And then I'll add an else. And then go over and pull in this Flea armor. And then we can get rid of this. And go over to the splat config and find Flea armor. And we're not going to get it from lib PSP anymore. We're just going to get it from lib, live lib, which is great. We have one less function that is, or one less file unique to the PSP. So I'm going to run a make extract again and make J, and I'm going to be very mad what? I may have to change a make file. I'm gonna try this first, and then I'm getting the wrong version here. So why are we getting the wrong thing? Did I not? Let me try flipping this around. I was pretty sure I can conditionally include these. Oh, what is going on? We are doing this a lot in the library. Huh. I'm not sure what is causing that. And there's other headers that that are responsible for setting that macro. So it should be set. Let me do one more thing. I just want to make sure that it's not. Oh yeah, so we may have to add this here as well. And if this doesn't work, then I am not sure what the issue is, but I will. I'll do something slightly different. Yeah. Yeah, I'm not sure what's causing that. So for the time being, I'm just going to get rid of these macros altogether and build again. And I expect this to build fine and work. But it's not. It's not. So maybe I do need the merge. So here we have the wrong name again. So I'm going to give that a symbol on both sides. I'm going to call it just entity Flea armor. And that will resolve that. So on the, I do need to add symbols for both of those. And give that the name or the address of this function. also just double check whether or not there's a text reference to that anywhere. And there's not. So as long as it's just extracted assembly, that's fine. And then I need to do the same thing on the PSP. So we're calling this function entity flea armor. There's always one reference to entity functions, which is in the entity update table. And that table is basically used to abstract an entity from the main game engine. So entities are indexed by an ID, and that ID is just what update function to use from that table. I think that is fine. So now I'll have to run an extract one more time. And we'll see if this works. Oh, so things that haven't been touched aren't rebuilt, because that's the way make works. So I'm just going to touch all the C files. And so those just have stale symbol names. And that's possibly what was happening before as well. Oh, we still have a stale symbol. Did I not extract as PSP when I did this before? Let's look at this data and see. I can update this manually as well. Cleaning would help this, but I can do it either way. Yeah, it's still this didn't get updated. Oh, because my address is wrong, of course. I used the PlayStation address. That was the issue. So let me touch the splat config again. And I probably have to touch all the C files, maybe. Oh, no, I don't. Okay. So, like I said, I'm not sure why. Let me close most of these. Not sure why the macro is failing here. I'm going to try to get that working one more time, because it'd be nice to check this in with both sides working. Yeah, no, it's still not working. So why? Why? So this should definitely be broken. So this was oh, maybe that's it. I see. I'm dumb. The location that it's extracted to, because I changed this name, will change as well. So let's just double check that as well. and see if I can find the right thing there. That is the right location now. I don't think that's going to help, but let's see. Seems like it's trying to expand that macro regardless. I really thought that the right thing would be done. And I really thought that there were other places where we had shared the files, and maybe that's changed since the last time I looked. So I can't have those together in the same file, so let's decompile them. And I'm going to start with the PSP this time. Usually I don't do that, but I am going to start with the PSP. And then PlayStation will have to suffer with PSP symbols. So let me grab that file. And then go over to M2C. No, not M2C. Decomp.me. M2C? Yeah, you know me. Let's look at whether or not that's an entity. And if it's an entity, then we can, it's in the entity updates table. That means we can use the standard void signature with a self argument. And let's go. Nice small function. Some types that we don't know of. A macro that ooh, I don't want preset. I want Symphony Night. So we have a couple function signatures to fix. I think both these are void with a entity pointer passed in. And then we need to figure out what these types are. We may be able to tell the types based on what we see down here. So this FF10, let's get a new decomp. SP10 is going to be an entity. My guess is that these are XY values, but we'll see with a new decomp. That would likely make these 0.32s. But they might be 0.16s. Actually, yeah, 0.16 is more likely. So we have the stride is 32 bits for the members of this array, and we're grabbing something at offset 0 and at offset 2, and then the same thing down here. I'm gonna make that assumption before doing another decompile because I think that's pretty safe. And then this other one is an init. And so let's run decompile. Well, it's still not happy. Happier. And how are we doing for compiling? Compiling. This initialized entity was redeclared. Okay. All right, 62%, not great. Not great. All right, so temp S0 is going to be an entity. I can tell by the stride, and the stride is BC, which is the size of an entity. Any place, so we're looking at the entity before the current one, so this probably has something to do with the explosion of the Flea Man armor. I don't recall specifically. So I'm going to replace temp S2 with previous entity, or S0, sorry. This SP10, that's all going to be self. And I'm going to get rid of this other variable. Temp S1 looks like the current frame. I don't think a separate variable is being used, so we can make a variable called anim per frame, and that's going to be not signed 32, but an unsigned 8. And we can tell that by all of the masking that gets added. Masks everywhere. Here we're just doing a minus equals 8. So this is some repeating animation where we're cycling through. I don't know why it's not just a mod 8, but it's not my code. I don't get to choose. This is going to be -1. All right, and everywhere that we had, well, was it Varus 1 originally? I've forgotten already. No, it was, I see. Temp S1 is what it was originally. I don't think this... so everywhere that there's a var S1, it should be anim current frame. And I'm going to include the mask in here because the mask is completely unnecessary. Then var S1 should be able to be removed. So this ended up being a pretty simple function. I'm glad we could get that done. All right, so a few things. We have self equals self. We don't need that. Not checking against the value 0, but doing a not for truthiness. Extra masks that appear to be not necessary. And I don't think we need these casts either. Oh, these are unsigned though. So we're loading hitbox dimensions. Let's see if there's a point U16. I don't know that there is. And the last one here is that. So the only thing that's missing is that these are being loaded as unsigned values when they should be signed. So let's see if there is a a fix for that. So let's see, is there a point U16? No. Let's find the point structure, and there should be other things nearby that we may be able to leverage. So we have a UV pair, but that's 8 bits. So really I want a I want a U16 height. So we have entity extension. In Coco, this is called a, what is it called? Size 16. I might make that. It doesn't make sense to have negative size, so we can force it to be a an unsigned. So we're going to have unsigned 16. What comes first, height or width? Width. And an unsigned 16 height. And we'll call this size 16. And we'll give that second array type of size 16, and then we can call this width. And this one height, and that should solve, and we have a match. All right, so on the PSP side, we should be able to take this over and grab that. We've got to grab everything from the context as well. And that should compile. Famous last words. And it does, great. So I need to decide now, am I going to use the PlayStation addresses and symbols or the PSP addresses and symbols? Sorry, PSP, but we're going to go with the PlayStation ones. I know I'm cruel. But what can you do? So we need all of these, and we also need the those will go in the PSP symbols. We need to grab the PlayStation symbols, and what are the PlayStation symbols? It'd be nice to give this a name. As well. Oops. I'm going to do a few things to clean up here. All right, so the PlayStation function was named this, OOC4. So I am going to rename that with that function name, which means I need to add a symbol for that function in the mapping table and give it the address of our current function. And then we need to go and find this function on the US side, PlayStation side, so that we can get the offsets there. I set my screensaver in KDE to not come on. Oh, come on. For 2 hours. That didn't seem to work. My other screen keeps going blank. All right, so the first one is the argument to initialize entity, which is this A0 field. So our symbol is this one here. which goes with this bottom one. No. Oh, there we go. And then we should have two more down here. Here's the first, and here is the second. And grab those as well. So now we have to go through and replace all those symbols in the function as well. So 268 is that. Oops. DD6. Sorry. F18 is DD6. No, that's not what I wanted. I wanted this. And then F10 is this guy right here, DD4. So then build one more time. I am going to extract. For some reason, oh, gotta fix them up here as well. This I don't think is going to match on the PlayStation side, but we'll see. And I'll tell you why in a second. We don't care about that at the moment. I think the data type is different on the PlayStation. So working on PSP. Let's try it on the PlayStation as well. If it does, great. But I think that there is a type difference. Maybe it won't matter. Yeah. And let's look. So we just have a few instructions, and the issue is these are nope. This is a 0.8. Do we have 0.8? I don't know. We don't have 0.8. So I need to make a 0.8. And I'm going to try a signed 8. I don't know if that's going to be the case. And let's try again. Nope, still failed. And it's, oops, no, not all that. A bigger issue. So it's not that either. Let's try this. Try to force the load as unsigned. Shoot. Shoot! I screwed up. I screwed up. I screwed up. I think I forced symbols. Oh, fortunately I have these open still. Okay, that doesn't look good. I think we're okay. It'll just be a slightly longer build, but that's okay. Not showing my terminal. You didn't see me screw up at all. Everything was fine the whole time. Everything was fine. Not cheating. Not cheating. Okay, we failed. That wasn't it either. So let's grab this PlayStation version and see what is going on. Uh-oh. Uh-oh. Drat. Oy. Carefully, carefully. I want to be able to go redo my changes. All right, let's see. This is if I do the wrong thing, I will lose all those changes, and I don't want that. So I'm going to be very careful. I needed my include ASM line back because that's what tells Splat that it should extract the assembly. And I want the assembly extracted. And now I should be able to cut. That worked. Okay. So let's make a new scratch in decomp.me. This time PlayStation. I'm going to fix grab our signature for this. I have all of these types. I'm going to grab those as well and throw them into the context. And then there's nothing with primitives here, but I'm going to fix the primitive, which has the PSP version. Which doesn't work anyway. Then we have the, I guess we have two different versions of this. The one that I have in my editor and the one that's in decomp.me. So we should have this completed. What is this? Again, custom, not what I want. I want Symphony of the Night. So we have a diff that's very close, but not quite right. Immediate values, not concerned with those. That is the only difference. Oh, no. Oh, yeah. So 4 plus 2, that's fine. This is wrong. This should be DDC. Okay. So why did I have DD6? I don't know. Oh, I grabbed the wrong value. That's why. Stupid. That's all. Just being stupid. And that works. So just to double check, I'm going to export version PSP EU. And that should be fine. Except that I screwed up the symbol. Too much to remember to do. It would be really nice to. There we go. To have these modeled correctly. So building on the PlayStation Portable. Building on the PlayStation. So we have, not only do we decompile another function, but we have code that is equivalent on both the PSP and the PlayStation. So I'm going to get that cleaned up and then I'll send it a PR, which is nice. So progress made on both sides of the library. We've been decompiling part of Symphony of the Night. This is a function related to the Flea Man armor. I think when the Flea Man armor gets broken and explodes. If you're not familiar with the Symphony of the Night decompilation project, you can go to soten.z.dev and learn more. We were working on the annex of the long library, one of the last functions remaining to decompile there. I mentioned earlier some of the other work that I've been doing. There's so much work that goes into a project like this, not just the decompilation, all the build tooling, all the research that goes in. Mozilla was here yesterday. Eldritch has been on before, so all the stuff that they've done in the randomizer community with offsets and types and different things. So much goes into this project, and when it's done, you're running Make just like you would on any other piece of software, which is awesome. So huge shout out to everybody who's working on Soten Decomp, all the tooling that's been done, and all the research. Thanks for everybody on the wiki as well. The Soten fandom wiki has a lot of just great information about playing the game. Really appreciate everybody that has come before and allowed me to be able to work on this project. Like I said, though, if you want to know more, go to soten.z.dev, join us in Discord, and see the source code that we decompile here and a lot more at the source code link, which will take you to GitHub. And if you're interested in joining, feel free to chat, feel free to like, subscribe, do all the things, and me or somebody else might help you get set up and going. But that's all I have for today. Appreciate you all. Adios.